Focus, please. Before I get started, I'm going to do a quick intro, and once again, how we can see slope at work everywhere, and to clarify some doubts that you had maybe from last year to this year. Now, last year or previous years, you were introduced to slope. Pay attention, please. And some of you had an idea in regards to lines and slope, and that's stuck in your brain, right? This year, I want us to make sure we understand what slope is in relation to what it really is, instead of just looking at a line, okay? Can you get the lights, Julian, please? So, for example, every now and then we meet as a math department over there at the high school. Sometimes we meet over here in my room. So this one time that I was over there, this lady was outside with her daughter, and they were asking me for directions to Frank Wright. They asked me if I was a teacher over there. I said, no, I'm not a teacher of Frank Wright, so let me give you directions. So I busted out with my smartphone, and I went to Google Maps. There it is. So check this out. So in Google Maps, I showed them, okay, we're right here in Imperial High School, and there they are. You see them right there? Oh, I see my house. So I said, guys, focus. I said, this is Imperial High School. Frank Wright is over here. So I said, get in your car and drive through these homes. And that's how you get to Frank Wright. No. No, we don't give those kind of directions, right? So, I know. Imagine if I did. So, I'll be like, Saturday Academy. No. So, what I did tell them is, in order for you to get from here to here, check this out. You need to take these streets. Do you see how there's streets right here? Yes, I see them. Okay, so then I want you to go through this parking. It's going to be open on the other side, but I'm going to count the streets. So you're going to go up 1, 2, 3, 4, 5, 6, and 7. 7 streets up, and then you go to the right from here. You go 1, 2, 3, 4. 7 streets up and 4 to the right. Well, guess what? The ratio of this to this, that's the slope. The reason I did this on purpose, I was being sarcastic, you're not going to drive through homes, is because the line is not the slope. Tell you never what I just said. The line is not the slope. What the slope is a ratio of the rise, which is this, over run. Now check this out. I always use this to make my fraction. 7 over 4. That is our slope. The line is not our slope. What is our slope? The rise over run. Does everybody see that? All right. So once again, not the line. Yes, we see the lines and we can tell whether it's a positive or negative line, but that's just to give us reference as to which direction it's going in inclination. Okay? So with that said, our objective for today, I can define and find the slope of the line. Let's read together. 1, 2, 3. Let's read again. 1, 2, 3. I can define and find the slope. Bam. All of you are ready to rap. Lights, please. Yeah, you're not rappers right now. I'll make you rappers by December. Because you're going to be wrapping gifts in December? Thank you. Or some of you wrap tamales, no?
I like tamales.
All right. Tell your neighbor the concept for today, please. Concept.
Slope.
Okay, thank you. Now, that's what's going in your Freire model, right? Slope in your Freire model, please. Here we go. Slope. What is slope? Slope is the change in y value, which is a rise, per unit of change in x value, run, which is always the same. Another word for always the same would be what? Always the same, which is constant. 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 Also known as rise over run or the slope of the line. Copy that. And also, as you're writing slope right here in the center, I want you to do this. so that you remember, from now on we're going to use the symbol M for slope. M for slope. Now, so that you remember what symbol we're going to use for slope, think of it like this. The first letter in the word mountain is M. And what do we find in the mountain? The slopes. Bam. Copy that, please. So, it says, slope is the change in Y value, also known as a rise. Everybody saw how we showed the lady to go up, right? Per unit of change in X value, which is a run, that's always going to the right. It's always the same, and another word that I use for always the same is constant. What is the word?
Constant.
So the slope is constant, also known as rise over run or slope for the line. Now check this out. Rise over run, it's a fraction. There it is. Rise over run.
I can't even see. I'm going to the arm.
All right, okay, let me zoom in. There it is. Rise over run. Notice that I did the rise kind of stretched, and the run going to the right like it's running. You see that? I'm telling you, put all these special effects. You guys don't even pay attention. There it is. It's running. Now check this out. Now each of those values represent a variable. Watch. Run represents the variable X. And notice if I put a little head right here, it looks like it's running. Be nice. No, it's running. Some of you run pretty weird. I've seen you guys run, so. Anyways, and this one represents the variable Y. And look, if I put a little head right here, it's like rising, like this. Boom. There you go. Anyways, you get the idea, right? So watch. Let me show you the different types of slopes represented in a line. So watch. This is a positive slope represented with this line. Negative slope represented with that line. Undefined and zero. Copy those. Now, I think now we have them here in the valley, but for those of you that are leaving the valley, there are these apparatuses that you're going to encounter once you leave the valley that, check this out, that there's these apparatus almost everywhere you go that what you do when you step on a step of it, all of a sudden it takes you up like this. They're called escalators.
Oh my God.
So, check this out. Escalator. So watch. So from now on, once we already started with graphing. From now on, I want you to think of the graph, the coordinate plane. We're always going to read it from left to right, just like we read an essay, just like we read any text. We're always going from left to right. So look at this line. To tell what kind of slope that is, I'm going to imagine that I get on the escalator, and check this out. It goes up from left to right. Look at this line right here. I get on, and it takes me down. That's why it's a negative slope from left to right. Now, check this out. This one, we don't know whether it's going up or down. That's why it's undefined. Undefined. Here we go. And this one, look up, This one, since it's not an escalator or anything, I just stand on it and it doesn't take me anywhere. Oh yeah, at the airports there's this other one, but it's not an escalator. That's called a Terminator, I think. Yeah, whatever it's called. So, check this out. So once again, this represents a positive slope going from left to right because it's going up. Negative slope from left to right because it's going down. Undefined because it can go in either direction. And this one is 0 because it's completely flat. So, let me show you some non-examples of what slope is not. Now, slope we said was the rate of change, that it's always the same, or what is the key word that I said? Constant. So now let me show you non-examples. This is a non-example of something that is not slope, and this is not slope. Copy those, and then as you're copying them, start thinking why those are not an example of having slope. Copy that. Let's see. How about this one? Chris V. Why is this a non-example of slope? It's not straight. Or what is the key word? Thank you, Chris. Yeah, because it doesn't have a constant rate. Look at this one. It starts as a positive, but then it breaks, and then it continues again. It's not a constant rate. So, how about this one right here, Patrick? Why is this not a constant? It's curved. It starts as a negative, and it goes into a positive, 0, and then up, right? So, the most important thing to remember about slope, number one, that it's rise over run. And it's found in linear equations or straight lines. Copy that, please. If you want to write somewhere in there also the word, it's a constant rate. That's fine. Okay, copy these 3 steps. Step 1, identify 2 points on a line or a table and write the coordinates. Identify 2 points on a line or table and write the coordinates. Step 2, compute the vertical change over the horizontal change. And step 3, simplify. Copy those, please. So, once again, 3 basic steps where you identify 2 points on the line or a table, write the coordinates, compute the vertical change over the horizontal change, and simplify. So, get your coordinate plane, the big one in front of you. I'm going to give you 2 coordinates. I want you to plot the points first. The first point is -4, -1, and the other point is 4, 3. Plot those points, please. Go. All right, here we go. -4, 1, and 4, 3. You should be done plotting those points already, right? Okay, check with your neighbor, see if they got the plotting correctly, please. If not, help them out. Okay, let's see. Look up. -4, -4 of x, -1 of y. -4 of x, -1 of y should be right there. Hands if you got that. Okay. The next one, 4 of x, 3 of y. 4 of x, 3 of y should be about right there. Next, you're going to get your ruler, and I want you to draw a line through those 2 points. Make sure you extend it all the way past the coordinate plane. All the way through. Yes.
I don't think mine goes that far.
Get another one. They're back there. Focus, please. All right. Your attention, please. Make sure you draw arrows at the end of the line that you just drew, or else it's not a line, it's a segment. Are we there so far? So now check this out. We're going to find the slope between these 2 points. Imagine you're looking at the map that I just showed you at the beginning, and we're going from left to right. So we're starting with this point. So to give directions to the lady, we go how many steps up? 1, 2, 3, 4. 4 steps up. How many to the right? 1, 2, 3, 4, 5, 6, 7, 8. 8. So our slope, we said M for slope is rise over run. Is that correct? So therefore, what was the rise? 4. What was the run? 8. Can we simplify that? This becomes 1 over 2. So my slope is 1 up and 2 to the right.
What does M stand for?
Slope.
I know, but why M?
We'll talk about that later. Yes? Yeah, that's fine. So, are we there so far? Now check this out. I'm going to plot another point. I want you to do the same. Let's plot 8, 5. Plot 8, 5 on your on that same one. And it should be right on that line that you just drew. Is that correct? Now check this out. Now I'm going to find the slope to this point. Now, do you want me to use this point to this point or this point to that point? This one to this one? All right, let's do that. But I'm going to switch colors. I'm going to use blue. So I'm going to go from here all the way over here. So how many steps up? Let's see. 1, 2, 3, 4, 5, 6. So that is 6. How many to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to write that up here. That's 12. So my slope is, what was the rise? 6 over 12, which is what? 1 over 2. So my slope is 1 over 2. Let's find out. Good question. So now I'm going to use the other points that you guys wanted, these 2 points. So let's see, I'm going to switch to red. So I'm going from this point to this point. So let's see. How many steps up? 1, 2. How many to the right? 1, 2, 3, 4. So my slope is, how many, what was the rise? 2 over 4, which is 1/2. So what do you guys notice? Everything reduces to. So think about this. What would be a key word that you would give your neighbor as to why this is on all those points, from points to point? Because it's a constant rate of change. So here's a question for you. Think about it. Guys, focus. Here's a question to you. Does it matter what 2 points I choose from this line? Think about this question. Does it matter which 2 points I choose from this line? Would I get the same slope, or would I get something different? Talk it over with your neighbor, please. And tell them why. Tell them why. So I heard some of your conversations, and I heard because of constant rate of change, it would always be the same. Is that correct? Now, what did it reduce to? 1 over 2. What does that mean? 1 step up, or 1 of rise, 2 to the right. So what does that mean for all of these? Let's find out. I'm going to start at this point. 1 up, 2 to the right. Is it still on the line? Yes. 1 up, 2 to the right. Is it still on the line? Yes. 1 up, 2 to the right. Is it still on the line? Yes. And that is our constant rate of change to make that line. Yes. Well, it depends on the direction of the line, yes, and the inclination. Okay? So now, notice this line, it's a positive slope. Does everybody see that? All right. Copy these next ones, please. You can use that same one, the big one. Plot these 2 points. You can use the same one, or if you want to switch to the other big one, that's fine. -2, 6, and 2, 3. Find me the slope, please. Copy that, draw your line, and then find me the slope. Go. All right, let's see. -2, 6 is about right there, and 2, 3 is about right there. So my line has to go through those 2 points. Is that correct? So let's see. We're going from left to right. Which is my first point? This one. My second point is this one. So I'm going from here to here. How many steps up? None. We have to go down. 1, 2, 3. If I went down, therefore it's -3. Then I go to the right. 1, 2, 3, 4. Therefore, my rise was -3. My run is 4. Hands if you got that. Now check this out. Look at the line. Look at the direction. Is it a negative slope?
Yeah.
Yes, because it's going down. Do you guys see that? Now, for those of you that did not include that negative sign, make sure at the end you look at the line and say, oh, it's a negative slope, and remember to put your negative on the slope. Okay?
So all negative slopes are equal to negative 3/4?
No, all negative slopes are negative.
Okay.
Yeah. So check this out. Look up. So this is a positive one. This is a positive. This is a negative. This is a negative. This one is undefined, and this one is 0. Everybody understand that so far? Now, here we go. Look up, please. Now, I'm gonna challenge your noodle, so pay attention, please. Here it goes. I'm gonna place 2 points. There you go. Now, I'm not going to use any numbers, so pay attention, please. Here we go. We have 2 points. I'm going to say, since we're going from left to right, this is point 1. This is point 2. Are we there so far? So, let's see. What would be the coordinates of point 1? And what would be the coordinates of point 2? Let's see. This we know has an x value, is that correct? So does this one. This one also has a y value. So does this one. Okay, I'll wait. You guys ready? All right. So this is x, this is x, this is y, and this is y. So, what are the coordinates for the first point, Sergio? There's no numbers. We just have variables. Yes. X and Y. Okay. So then, what are the coordinates for the second point, Idalis? X and Y. So if I gave you these two coordinates, how are you going to know which is point 1 and which is point 2? Jonathan? Yes, but we're not looking at this. We're looking at this. How are you going to know which one is the first and which is the second? Pay attention, please. Unless we do what? Let's see. Erica. What would we need to know or to do to distinguish from one from the other? Dylan. Label them. How? One next to it. So I'm going to do X sub 1, Y sub 1, and therefore this is what? X sub 2, Y sub 2. Are we there so far? Okay, watch. Hold on. We're not done yet. So now, with that said, let's say I gave it values. 2, 6. We're almost done. 1, 8. Watch. To find the slope, to get from here to here, how many steps do I go?
7.
So what do I need to do to these two to get 7? Okay. Steps from here to here are 4. And what do we do to these two? Subtract. So check this out. So to get my Y value, we did what? 8 minus 1. Is that correct? To get my X value, we do what? 6 minus 2. And that's where we get, check this out, Y2 minus Y1 over X2 minus X1. You guys remember that one? Because it's distances. So home plate for tonight. Pages. Hold on. I need you guys to put away your rulers also. Pages 176 through 178. Have a good one, guys. Enjoy your home play. See you guys tomorrow.